Hi, welcome back. Welcome to Unacademy. Unacademy is the India's largest online learning platform. I'm welcoming you all to this beautiful online learning platform. Now we are happy to announce that Unacademy is going to providing online training for GATE and engineering service examinations. Here your classes are handled by India's top educators who are qualified in engineering service, toppers in engineering service exam, toppers in GATE exam, toppers from IITs and well experienced faculty. Okay, these are the faculty are going to handling the subjects. About myself, I G Venkatrao, I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now here we check how to get Unacademy learning app into our device. Just go to Play Store, type Unacademy. By typing Unacademy, it will shows the Unacademy learning app like this. In this, by clicking on this install button, it will install the Unacademy learning app. Now, by joining this Unacademy, what you will get? This is very important. See this? So, you observed or not, there are so many benefits by joining in this. See this? What you are going to be getting here? First one is daily live classes. So, my dear students, if you join it outside for taking offline training, okay, now most of the cases your offline training is at weekends and during public holidays. During that time only you have you have offline classes. But here every day you have a live class. Every day you have a live class. So due to this, you are going to be continuously in touch with the subject. Continuously in touch with the subject. And one more very important thing is, once you are attending offline class during weekends and public holidays, from morning to evening continuously you have to be sit there and listening the single subject 8 hours, 7 hours, 10 hours. How much hard it is, how much pain it is. Even in colleges also, most of the students are sitting up to morning session, they will attend, most of the attendance we observe. But afternoon session, last 2 hours, very few attendance. Because our mind is not supporting. Okay, so every day you are getting live class. So you can come out of that mode. Now by attending daily classes, live class, you can always in touch with the subject, okay, and try to solve more number of problems and continuously chat with your educator, that means faculty, engage in discussions, you can ask your doubts, okay, and you can answer the polls also. Okay, so these are the advantages you will get by joining Unacademy. This is the first thing. Second thing is structured courses. So see, almost all the students are starting at beginning, they will see the syllabus and they start their preparation. After some time, that means after 1 month or 1.5 months, they won't consider about the syllabus. They are concentrating only on the topic, this topic, next extension topic like that. In that case, some of the students are deviating away from it, whatever the basic thing we required. Unwanted syllabus they are moving towards. So to avoid that, here all our courses are structured in line with your exam syllabus. Every course is structured well with your exam syllabus. Okay, that is helpful to you for best to prepare for it. Next one is live tests and quizzes. Now this is very important. You are feeling that your preparation is completed. Okay, you are saying that I am strong in transistors. Okay, you are strong. Okay, I am accepting it. But where is the proof? Where is the proof? Now I will provide the proof to you. Say this. Just by attending our regular mock tests and quizzes and by analyzing the results, you can get your performance. That is the proof. So to evaluate your preparation. You can evaluate your preparation with our regular mock tests and quizzes and get detailed analysis on your performance. Next, unlimited access. Here, once you are taking the subscription, you can get an access to all our live as well as recorded courses to watch from the comfort of any of your device. Whatever the device you are feeling comfort, okay, you can watch that one from that device. You can use either mobile, laptop, desktop or tab, whatever it is. That is, choice is up to you. Okay. Next. Here two subscriptions are there. First one is Iconic subscription. Second one is Plus subscription. Okay. In Plus subscription, what are the things previously explained? Daily live classes, structured courses, live tests and quizzes, and unlimited access. All these things, all the benefits you are getting here. Okay. All the benefits you are getting here. Next. Now, in Iconic plan, see, Plus subscriber, what are the benefits got by the Plus subscriber? In addition to this, you are going to getting 3 additional benefits: personal coach, study tracker, mains question and answer practice in Iconic subscription. Okay, this is the recommended subscription because we will take your GATE and engineering service preparation to next level with personal coach. Now here, what is personal coach concept? Say this. Here you get one-on-one guidance. Every individual student is guided personally, individually, from top exam experts. Top exam expert is going to guide you. Okay, he is acting as your personal coach. He align your preparation strategy and learning resources. What it means is, once you've written some exams and quizzes you attempted, based on your performance on that, they will prepare a report, and that means they are going to identifying the gaps in your preparation. To fulfill those gaps, what you need, so they will prepare proper study planner to you, and respective material also they will provide for that respective topic. Okay, so that is the function of the personal coach. Second thing is, you can get the study tracker. So I want to know my progress. Okay, to get that, by participating in study tracker plan and study booster workshops, you can evaluate your progress in bi-weekly reviews with personal coach. Next, mains question and answer practice. So here, to strengthen your mains answer writing through regular practice with evaluation and personalized feedback. So to strengthen your answering capability to a question, you can write answers regularly, you can practice, and that answer is going to be evaluated, and based on the evaluation, after that, based on your answer, they will provide the proper feedback to you. Okay, these are the additional things you get compared to Plus subscriber. As a Plus subscriber, what are the benefits got by the Plus subscriber? You are getting all those. In addition to that, you are getting these 3. Clear? Next. Now, common emitter amplifier. Already last session we started this common emitter amplifier. Here we went for circuit diagram first. That is, a properly biased transistor is a self-biased circuit. Okay, so last session we completely concentrated on circuit diagram of the amplifier. How to draw the circuit diagram of a particular respective amplifier circuit diagram. Okay, no need of any by having any circuit. Okay, by applying simple technique, you can draw the any circuit diagram. Next, in amplifier analysis, I am going to doing amplifier analysis. Some of the students are told me, sir, I done the analysis of the amplifier, sir. I completed it. What you done in analysis? Sir, I calculated input impedance. Wow, very good. From the input impedance calculation, what you gained, what you understand, what you understand. Sir, I calculated RI, sir. RI of input impedance of CE amplifier, HIE by 1 plus HFE, sir. HIE plus 1 plus HFE into RE, sir. CC amplifier input impedance. Okay. That is okay. That is equation. Fine. You derived it. Okay. From that, what you gained? What is your knowledge from that? Okay. You are giving the equation. Okay. Who knows simplification and substitution? They can also derive the equation for input impedance. But as an engineering student, what you gain from that? Why are you calculating input impedance? So far, anyone asked this question to your faculty? Sir, why we calculate input impedance? Please, my request is don't go for this and every parameter. Why we are calculating this parameter? Why should I calculate this? 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 You should know the reason for each and everything. See, don't worry students, I will give the reason for that. Now, so any amplifier you can take can be represented by a block diagram. Now, here in this input voltage and input current, this is the input side, this is output side, output voltage, output circuit current, and input can be replaced by its input impedance Ri. Now I am connecting input source to this. That means here we are connecting a source. The way how we are connecting source to this, okay, sorry, now, so this is circuit diagram. Yeah, why we are going to calculating all this? Okay, now I want to know that. See this. Okay, let us, I am connecting a input source RSVS this side. This is Vs and it is Rs. Okay. Now, as a source, I am feeling that I am giving the data input voltage Vs. I am giving data Vs to you. Okay. As an amplifier, you need to take the data and you have to amplify that data. If the gain of your amplifier, if your gain is 1000, my signal has to be increased 1000 times at output. That is what I am expecting. Listen carefully, sir. What I am expecting is, okay, if I give 1 rupee to him, if the gain is 1000, now 1 into 1000 rupees they will provide to me at output. That is what I am expecting. Okay, now I given 1 rupee to you. Here I given 1 rupee. 1 rupee I given to you. But once I given 1 rupee to you, in between me and you, there is a resistor Rs. In general language, we call it as a broker. He takes some commission. Okay, he takes some commission. He taken a commission of 20 paise. 0.2 rupees. 0.2 rupees he taken. 0.2 rupees. Now, here it reached 80 paise. That means 0.8 rupees it reached. That means, according to amplifier, you given 80 paisa. But according to me, I given 1 rupee. At output, I am expecting 1 into 1000 rupees. But maximum at output, you get 0.8 into 1000, 800 rupees. Now there is a 200 rupees variation. Okay. Now, in practical case, to know about how much portion of input signal is reaching the source signal is reaching the input terminals of the amplifier. I am giving 1 rupee. Okay. If it is reaching instead of 0.8, if it is reaching 0.95, then I will be happy. If it is 0.95, then I will be very happy. Okay. So now, is this much part is reaching at input or not? Actually, how much it is reaching? To increase this from 0.8 to 0.95, what I want to do? To get all these things, first you should know what is the input impedance. Because based on input impedance only it is decides. It decides. See, this is the relation. Vi is Vs into Ri by Ri plus Rs. Okay. So first I want to know that. So from this we calculated. So practically at output side, output resistance R0 is there. This is plus minus. This is our V0. Ideally we are expecting V0 is AV into Vi. But here is output impedance R0. It is going to consume something in this. So some voltage drop takes place across this. Remaining is going to reach the load RL. That's it. Here also we are expecting 800. Okay, you got 800, but in that 800, complete 800 is not forwarding to load. Some drop takes place here. Okay, so hardly 600 reach the output. Now we are expecting 1000, but instead of 1000, only 600 reach the output. See, 400 variation. So to know about or to forward complete amplified, this is called amplified signal, sir. AV into Vi is amplified signal. To forward maximum portion of amplified signal to the load or output, what is the output impedance required? So the same way, what are the procedure we followed previously? By following the same procedure, you can take R0 0, ideal conditions. If R0 is low, then drop across this is low and most of this part is reached the load. Okay, so to know about how much input, how much source signal is forwarding to the input terminals of the amplifier and how much amplified signal is forwarding to the load. To know about these things, we are going to studying about input and output impedances. Okay. Next, voltage gain and current gain also we are calculating. Why? Because you are saying your amplified gain is 1000. That means input signal is increasing 1000 times at output. Okay, that 1000, I want to know how much it is. It is 1000 or 900 or 800, practically how much? For that we are calculating the gain. So two gains we are calculating, voltage gain and current gain. Okay, so this is the thing so far we complete. Now, okay, now we have a properly biased circuit here. Now what I am going to doing is I am taking CE amplifier. For that CE amplifier I am going to calculating all the parameters what I mentioned previously. Input impedance, voltage gain, current gain, voltage gain and output impedance. I am going to calculating all this. Okay, now it is a analysis of CE amplifier. Okay, next. Now analysis of CE amplifier. Amplifier. See this, from the knowledge of the CE amplifier, we write the equations for CB and CC also. Analysis of CE amplifier. First I am taking the circuit diagram. This is the properly biased transistor. Properly biased transistor. For this properly biased transistor, I am going to connecting additional components to convert this one into a CE amplifier. For CE amplifier, emitter is connecting to ground through a capacitor CE. These are external capacitor. What is the function of that capacitor? Everything we discuss in frequency response in detail. So at base you are giving input, at collector taking the output. Okay, CC, CE it is, and it is CB. So here you are giving input, here taking output, and at input side I am connecting a source RSVS, source voltage. Source voltage RSVS. This is the amplifier circuit diagram. Is it okay? Is it okay, sir? Next one. After that, here calculation of those parameters is nothing but a doing AC analysis. We are doing the AC analysis on the circuit. For AC analysis, just a minute, sir. I am copying the circuit. So okay, this is our circuit now, and I'm taking another copy. See this. Now we are doing the AC analysis. Okay, for AC analysis, what I am doing is for a series. Okay, for AC analysis. So now we are doing AC analysis. So calculation of those parameters comes under AC analysis. In AC analysis, for doing AC analysis, we need AC equivalent circuit. Therefore, we need AC equivalent circuit. AC equivalent circuit. Okay. So we need AC equivalent circuit. How can we get AC equivalent circuit of CE amplifier? Simple. So to get AC equivalent circuit, you need to apply few sequence of steps. Okay. Now to get AC equivalent circuit, of any amplifier, the following procedure has to be applied. Has to be applied. In that, first step is for AC circuit, for AC signal, all external capacitors are short circuited. So all external capacitors so the external capacitors what we are using is CB, CE and CC. All external capacitors are short circuited. second one is DC supply connected to ground. DC supply. In this circuit, our DC supply is VCC connected to ground. Third one is redraw the simplified circuit. Next, redraw the circuit and use, okay, redraw the circuit. Simple, that's it. And after redrawing the circuit, we are going to replacing your transistor by its H parameter. That's it. Okay, then by redrawing the circuit, you get the AC equivalent circuit. Now I am going to this. This is my circuit. How to get that? So first step what I am going to applying here is see this. Now step 1 here what I am applying is all external capacitors are short circuited. All external capacitors are short circuited. Capacitors are short circuit. See, it means first I am redrawing the circuit. Here is your plus VCC. Now first I am short circuiting all external capacitors. Short circuiting this, and one more, sir. Here you can connect external load RL. You can connect it, it's not, otherwise no issue. Now your RC behaves like a default load. RL. All external capacitors are first short circuiting. Okay, this is short circuited. Okay, once all external capacitors are short circuited, what we observed is your emitter is directly connected to ground. So once emitter is connected to ground and no use of RE, therefore emitter resistance is bypassed by short circuiting CE. Now therefore emitter resistor is RE is bypassed by short circuiting by short circuit of CE. That is the result. So now it is going to be connected to ground. Okay, it is short circuited previous step, and here you connected load RL, and at the same time here we have plus VDD. Okay, and second step 2 is connect VDD to ground. Connect VDD to ground. That means 0. Now I am connecting this one to ground. Once it is connected, now I am going to bending. Here R1 is like this. Now I am folding this, and RC is like this. I am folding that because your collector is here. Your collector is connected to ground. From this terminal, collector connected to ground through RC as well as RL. Through RL also it is going to be connecting to ground, and similarly at this point base is connecting to ground through R1 as well as R2. Now I am going to taking the next circuit. Next, now your equivalent circuit is, therefore the equivalent circuit is Simply we have a transistor. Emitter, base, collector. So in previous circuit, emitter directly connected to ground because due to CE short circuit, no use of RE. So emitter directly connected to ground, and at base we have R1 connected to ground as well as R2 also connected to ground. Now R1 connected to ground as well as R2 also connected to ground. R1 connected to ground and R2 also connected to ground. Next, at collector, RC connected to ground as well as RL also connected to ground. RC connected to ground as well as RL also connected to ground. Okay, here you are taking output. This is your input, Vi. So where you are applying input, there I am going to taking the RSVS, and here we are taking output. Load is there. Now every time it is very difficult to draw these things completely. Now what I am doing is I am going to taking this parallel combination of R1 R2 is now onwards by RB. RB is R1 parallel with R2. Okay, and RC parallel with RL, I am taking it as RL dash. RC parallel with RL. Okay, that is RL dash. After applying all these things on this, our next circuit is like this. Now emitter, just you follow this procedure to draw the AC equivalent of any circuit. Collector, emitter, base. Okay, this is the, here I am going to drawing the AC equivalent of CE amplifier. Final AC equivalent circuit of, or AC circuit of CE amplifier. CE amplifier. Now common emitter, you are saying simply emitter connected to ground without second thought, just connect emitter to ground. At base, just at base connect biasing resistor RB. Base connect RB, collector connect RC. That's it. Now we called RB is the input biasing resistor and RC is the output biasing resistor. Next, here you are giving input and here we are taking output. To take the output, you can connect a load to that. You can connect a load RL to that. And at input side, you are giving just RS VS source I am connecting. This is the complete AC equivalent of CE amplifier. And now this is going to be RL dash. This part is RL dash, which is RC parallel with RL, just before we mentioned. Okay, now I am going to redrawing the circuit. Yes. Now here we are taking out, and at output we have RL dash. That's it, RL dash. This is your output voltage V naught, and this is your input voltage Vi, and this is input current, and this is output current. This is load current IL. Okay, now here input current we are calling it. It is nothing but a base current because it is base terminal, and output current is IC, collector current, because it is a collector terminal, so it is IC. And this is minus IC. IL is minus IC. Okay, this is IB. Now input voltage is nothing but a base to emitter voltage VBE, and at output voltage is VCE, voltage between collector to emitter. Why? Because this is emitter. Emitter is common. Emitter is common. Okay, now from this we can write output voltage is minus IC into RL dash, which is equal to, you are saying output voltage, but with respect to transistor, that is the voltage between collector to emitter, VCE. That is the voltage between collector to emitter. Now just hold it. Now we are going to replacing your transistor by CE H parameter model, but no need to place it. Just from the knowledge of equations also we can derive whatever the parameters we need. Okay, now here I am going to replacing transistor by its transistor by its H parameter model. Okay, no need to place. Now from H parameter, see, input voltage is VBE, input current is IB, and output voltage is VCE, output current is IC. So in this, these two parameters are taking as dependent parameters. Okay, by taking those two are dependent, we can write VBE is equals to HIE into IB plus HRE into VCE. Sorry, it is VBE, and output current IC is HFE into IB plus HOE into VCE. So these are very important. Instead of replacing transistor by its H parameter equivalent, just I am going to using these two expressions. Okay, now let us take equation number 1 and equation number 2. Okay, now I am taking this part of the circuit. First parameter what I am calculating is input impedance. Okay, so first parameter I am calculating is input impedance. RI, input impedance, RI. So we can write RI is input voltage by input current. We know input voltage is VBE and input current is IB. Okay, now this is going to be your input impedance RI. Okay, now I am writing that. See, just before we've written the equation for VBE, equation 1. Now I am writing that. From equation 1, VBE equals to HIE into IB plus HRE into VCE, and from circuit what we know, VCE is nothing but a output voltage which is minus IC into RL dash. By substituting this one in equation 1, we can write, therefore VBE can be written as HIE into IB plus HRE into VCE is minus IC into RL dash. Okay, is it okay, sir? Now next one, I am using that equation. VBE equals to HIE into IB plus HRE into VCE into, VCE we replaced by minus IC into RL dash. Just hold it. This is the equation you got so far. Okay. Now, what I am doing is I am going to calculating next current gain. Do one thing. Otherwise, first calculate current gain. Now it is easy to you. Then you feel comfort by calculating current gain first. So first I am calculating current gain. Current gain AI is load current by input current. See this, it is minus IC. The output coming, current flowing entering, current flowing through the load is minus IC by input current is IB. That's it. Minus IC by IB is the current gain. And from H parameter we know that, we know IC from H parameter. IC is H of E into IB plus HRE into VCE. But what is VCE from circuit? From circuit, VCE equals to minus IC into RL dash. Substitute that. Therefore, H of E into IB plus HRE into VCE minus IC into RL dash. This is your IC value. Now take this one this side. Therefore, it is IC plus IC into HRE into RL dash equals to H of E into IB. Okay, now I am going to taking IC common in this. Now, so it is IC into 1 plus HRE into RL dash sir, just it is HOE, sir. HOE, because we are taking output current. Yeah, now it is HOE into RL dash is equals to IB into HIE. H of E. See this equation. Yeah, H of E into IB. Now from this I am writing IC by IB is H of E by 1 plus HOE into RL dash. Therefore, current gain AI is minus IC by IB, which is minus H of E by 1 plus HOE into RL dash. This is the current gain of CE amplifier. Current gain of CE amplifier. Okay. Next. Now next I am going to input impedance, which is input voltage by input current. Input voltage is this one, VBE by IB, input current. Just I simplified. Next I got this equation. Now I am dividing both sides with IB. Therefore VBE by IB equals to HIE into IB by IB plus HRE into minus IC by IB into RL dash. Now these two gets cancelled. Therefore VB by IB is nothing but a RI input impedance, which is HIE plus HRE into AI into RL dash. That is the input impedance. Okay, so once you know the input impedance, immediately you need to go for equivalent circuit of the amplifier. Okay, once you know the input impedance, now the equivalent circuit of the amplifier input terminals can be drawn like this. Drawn like this. This is the base, emitter. Now the input impedance of this amplifier is Ri, just before you calculated. This is your Ri, input impedance of your amplifier. Voltage between these two is VBE. Current entering into this one is IB. Okay, now once it is complete, now I am going to replacing the base to emitter terminals of your transistor by Ri, this circuit. Okay, now see this. This is the input side circuit. After that, for this you connected base connected to ground through biasing resistor RB. And after that, here we have source RSVS. RSVS. Source like this. Okay. So now I am going to calculating another one. This is input impedance Ri, including biasing resistor RB. The input impedance of the amplifier is, see, including RB only it became amplifier. Without biasing resistor it is not amplifier. So whatever the Ri just before you calculated, that is the input impedance of transistor. Now this is going to be the input impedance of amplifier. Ri dash. We called it effective input impedance. Now its value is, so Ri is effective input impedance. input impedance. Now see this. Here RB and RA both are parallel. Simple. So it is RB parallel with RI. That's it. RB parallel with RI. Over. And at the same time I am going to redrawing the circuit once again. See, up to these two terminals it is RI dash. Now it is RI dash, RI dash. Between, now at input terminal we have, input side we have RS Vs. Here is Vs. Okay, now the voltage, whatever the VB here we have, here also same VBE. So same VBE we have. And this is RS. Now I am taking the input impedance including source resistance. Here I am taking. So I am calling it as RIS. So it is RIS equals to, simple, both are in series, RS plus RA dash. RS plus RI dash. Simple. Okay, now therefore RIS is called input impedance including source resistance. Input impedance including source resistance. Source resistance. Okay, input impedance including source resistance, that is the RI dash. Okay, next one. So after this we are going to voltage gain. So input impedance is completed. So far we have total, we got three different input impedances we got. In that first one is we got regular input impedance Ri, which we got is HIE plus HRE into AI into RL dash. HRE into AI into RL dash. Second one is RI dash, effective input impedance. Simple, RB parallel with RI. And third one is RIS, input impedance including source, which is RS plus RI dash. That's it. These are the three different input impedances present in that. Based on this circuit, in problem they may ask any one. Okay, you should be ready to calculate any value. So next one is voltage gain. Next, voltage gain. Third parameter is voltage gain. So voltage gain is represented by the letter AV, which is output voltage by input voltage. Okay, from circuit we know that. So we know V0 is nothing but a VCE, as well as its value is minus IC into RL dash, just before we calculated. At the same time, input impedance of the amplifier already we calculated, that is input voltage by input current II. So here V0 is nothing but a VCE and Vi is nothing but a VBE, input voltage. So from this, Vi is nothing but a VBE and it is IB. From this we can write VBE is just Ri into IB. Take this value and this value, substitute here. Therefore voltage gain is VCE by VBE, which is minus IC into RL dash by Ri into IB. So which is minus IC by IB into RL dash by Ri. But we know that minus IC by IB is current gain AI. So AI into RL dash by Ri. Sorry. Therefore, voltage gain AV is AI into RL dash by Ri. That's it. This is the voltage gain. Okay. Now, next I am going to calculating voltage gain including source, because so far we did not consider the voltage source. Okay. Now, voltage gain including source. Voltage gain including source. So I'm calling it as AVS, which is output voltage by source voltage, not input voltage, it is source voltage. Okay, source voltage. Now, your amplifier equivalent circuit including source is like this. It is Vs, and here we have Ri dash. This is your input voltage VBE. Already we derived this one. It is Rs. It is Ri dash. Okay, now, so if you go to the previous circuits, see this Vs, Rs, Rb, Ri. Now Vs, Rs, Ri dash, VBE. This is the circuit I am going to be using now. Okay, so now see this here, AVS, you are saying it as V0 by Vs. So V0 is nothing but a VCE by Vs. Now I am going to multiplying and dividing this with VBE, input voltage. So which is equal to VCE by VBE and VBE by Vs. VBE by Vs. Now, just before we calculated VCE by VBE, so we know VCE by VBE value is AV. Just before we calculated, see AV, VCE by VBE, AI into RL dash by Ri, just before we calculated. Next, we need to calculate VBE by Vs, how much it is. That's it. We need to calculate that. Okay, next. Here I am going to applying voltage division. Therefore, VBE can be written as Vs into Ri dash by Ri dash plus Rs. Therefore, VBE by Vs is equal to Ri dash by Ra dash plus Rs. That's it. Very simple. Now take this one and substitute here. Therefore, voltage gain including source AVS is equals to VCE by VBE, which is AV, into VBE by VS, that is Ra dash by Ra dash plus Rs. Ra dash by Ra dash plus Rs. That's it. So that is the voltage gain including source resistance, or including source. Okay. Similar way, I am going to calculating current gain including source. In that case, I will take this. See this. I will take this part of Ri and Rb as usual, but I replace this voltage source by its current source. Okay, that's it. Not more than that. Next, current source including source. Current gain including source. First, I am going to drawing the circuit diagram. So with biasing resistor, the circuit is in terms of input impedance. This is Ri, this is Rb, and this current is Ib. That is very important here. Now I am connecting source to this, current source to this. Is source current and Rs. Okay, here we need to calculate current gain including source, that is AIS. Now it is minus IC by, instead of IB I am taking it as IS. Now between IS minus IC and IS we have IB. So just multiply and divide with IB. Now it is minus IC by IB into IB by IS. So we know that minus IC by IB is nothing but a current gain AI, and we need to calculate IB by IS. How much? We need to calculate that. Okay, just a minute. Okay, now so in this I want ratio of IS and IB. What I am doing is RS and RB are in parallel. Now I am going to replacing this parallel combination by RS dash, which is RS parallel with RB. So okay, now the circuit became like this. IS, these two parallel combination replaced by RS dash. Here we have base, emitter and Ri. This current is IB. I'm applying current division. Therefore, IB can be written as IS into RS dash by RS dash plus RI. That's it. Now, from this we can write IB by IS is RS dash by RS dash plus RI. That's it. Now take this one right here. Therefore, AIS is AI into IB by IS is this one, RS dash by RS dash plus RI. That's it. So this is the value of AIS. Okay, AIS. Next one. So far we completed input impedance, voltage, current gain including source, voltage gain including source. Last one is output impedance. Okay, now output impedance. R naught is output voltage by output current at load disconnected. RL has to be disconnect and source voltage has to be connected to 0. This is the value of R naught. And for this circuit, for this transistor, this is the condition. Collector, emitter connected to ground. Here is output voltage VCE. Here is the output current IC. Between we have a load RC, external resistors RC as well as RL. Here at input side we have biasing resistor RB as well as RS. Here your Vs is there, that Vs is connected to ground. Vs is taken as 0. Under these conditions, this is going to be output impedance R naught, which is VCE by IC at a condition of Vs equals to 0. Okay. So once Vs equal to 0 and this is your RS and it is RB, this is going to be your Vi. VBE, it is IB. Fine. Here, both RS and RB are in parallel. Both are in parallel. Now, the equivalent circuit of this one I am taking as yeah. Both are parallel. Now we know that RS parallel with RB is nothing but it is RS dash. We know that. Now this part is, now at input side we have RS dash. Okay, RS dash. This is base emitter. RS dash connected between base to emitter. It is connected to transistor. Like this. and we know that this is our VBE, this is IB. So same IB is flowing in RS dash also. Same IB is flowing in RS dash also. Now, with respect to this side, so now this circuit I am redrawing like this. Yeah. See this? Now, from this side, you can write VBE is minus IB into RS dash. From this side, it is a VBE IB. It is a transistor input side. From H parameter, you can write VBE equals to HIE into IB plus HRE into VCE. Okay, now both are equal, both are representing VBE. Now I am equating this. Therefore, minus IB into RS dash is equals to HIE into IB plus HRE into VCE. From this, take this one this side. Therefore, VCE into HRE equals to minus IB into RS dash plus HIE. From this we get, therefore VCE by, IB by VCE I am writing as IB by VCE is minus HRE by RS dash plus HIE. Just keep it. Now we need R naught, that is VCE by, so this is the value of this is nothing but a IB by VCE at a condition of Vs equals to 0, which we got is minus HRE by RS dash plus HIE. Don't forget. Now VCE by IC, RC is. Now we know at the same time we want at the condition of Vs 0, because already we disconnected RC. We know the value of, we know IC value. IC is from H parameter H of E into IB plus HOE into VCE. HOE into VCE. Now dividing both sides with respect to IC. Okay, dividing both sides with respect to VCE. Therefore, IC by VCE equals to H of E into IB by VCE plus HOE into VCE by VCE. Both will get cancelled. Now it is IC by VCE at a Vs equal to 0 we need. So this is at Vs equals to 0. Once it is Vs 0, it is also at Vs equals to 0. Already we calculated IC by VC at Vs equal to 0. This is minus HRE by RS dash plus HIE. Now we can write, therefore this is going to be 1 by R naught. 1 by R naught we called it as output admittance Y naught equals to H of E into IC by VCE is, I write all these in the next slide. So this is the equation. Now this is nothing but a 1 by r naught. 1 by r naught we can call it y naught, which is h of e into its value is minus hre by rs dash plus hie. hre by rs dash plus hie plus hoe. Therefore y naught is 1 by r naught. Its value is hoe minus h of e into hre by rs dash plus hie. That's it. So that is the equation for y naught. Okay, so far we calculated the analysis of all the circuits. So once you calculated y naught, that means r naught, next you can do one thing. These are the output terminals of your amplifier. Here you calculated r naught. Immediately after r naught, here you have rb, RC, collector resistance, and including that you can call it r naught dash effective output admittance, output impedance. And if you want, you can add extra load also. Whatever the external load you have, you can add that one also. So then you can call it as r naught double dash. So here r naught dash is r naught parallel with rc, and r naught double dash is r naught dash parallel with rc. Now applying parallel combination is very easy to us. Because of that, we are disconnecting that. At the same time, if output load is connecting, there is a chance of changing output current. So at the to calculate r naught, we are making vs0. By connecting vs0, input current parameters are constant. If your input source is presenting, input parameters are changing. Under the condition of changing input parameters, it is very difficult to calculate output because it is a dependent source. You are replacing your transistor by a dependent source. That is the reason. Okay. Now, this is about analysis of CE amplifier. Okay. Now, whatever the parameters so far I got in the analysis of this, I am going to writing all the parameters. Therefore, CE parameters are CE amplifier parameters are I am writing directly, sir. First one is current gain we calculated, which is minus IC by IB. Its value is minus H of E by 1 plus HOE into RL dash, where RL dash value is RC parallel with RL. Second one is input impedance RI, which is VBE by IB. Its value is HIE plus HRE into AI into RL dash. And another one is effective input impedance RI dash, which is RB parallel with RI, and RIS input impedance including source, which is RS plus RI dash. Third parameter is voltage gain AV. So AV is VCE by VBE, which is AI into RL dash by RI. AI into RL by RI, RL dash by RI. So this is about parameters, and few more also is there. Now I am writing those also. So AVS, voltage gain including source. This is constant for all amplifiers. But at that time use that respective parameter. AV into RI dash by RI dash plus RS. Okay, and we know RI dash. Already we defined it. Fifth one. Current gain including source. AIS is AI into RS dash by RS dash plus RI, where RS dash equal to RS parallel with RB. And last one is output admittance, which is 1 by R naught. Its value is HOE minus HFE into HRE by RS dash plus HIE. That is the output admittance. So these parameters are very important, sir. Okay, so while analyzing this amplifier, CE amplifier, we are going to using these amplifiers directly. Okay, this is the analysis of your CE amplifier. Is it okay? Next. So the same way, same procedure we are applying to analyze our CC amplifier and CB amplifiers. Okay, so next session we go to that. See, here are our top educators. Tiwari sir, he is IIT topper. He got 7 years of GATE and engineering service exam teaching experience. And Ankit Goyal sir, he obtained All India first rank twice in GATE electrical. He was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir, he is the computer science faculty, having experience of more than 8 years. Okay. Now, Jaspal Singh sir, he is ex-IAS officer. He got All India 4th rank and he is a scientist, GATE, State Service Exam and PSU topper and ex-senior MedEasy faculty. These are his credentials. Here are few more top educators from an academy. Here also. So these are the different engineering disciplines available in an academy: electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. There are 2 subscriptions, Plus subscription and Iconic subscription. So in both the case, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. Here we are going to show the difference between Plus subscriber and Iconic subscriber. Now in Iconic we are providing a personal coach. He is going to, this data is forwarded to personal coach once test is completed. He do the personalized test analysis on that and prepare a study planner and respect to study material also. And for plus plan, these are the cost for it is available in different subscriptions: 1 month, 3 months, 6 months, 12 months, 1 year, 1.5 year, 2 years. For 1 year it is they are charging 30,250. By using my code VROUT10 during subscription, you get it by 10% discount at 27,225 rupees only. Don't forget to use my code VROUT10 during subscription. And the beauty here is you get EMI option also. Next, Iconic plan, it is available in 2 subscriptions, 1 year and 2 years. For 1 year it is 50,250. By using my code VROUT10 during subscription, you get it by 45,225 rupees only. Okay, so my dear students, outside situation is not favorable to us, so please restrict your movement and take a right decision. Whatever thing is happened at outside, your learning process should continue. So by joining Iconic plan in an academy, continue your learning process. Thank you very much. And don't forget to use my code VROUT10 during subscription. Hit the bell icon and subscribe us. Please give your valuable comments on YouTube and join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us. Once again, I'm welcoming you all to this beautiful online learning platform, Unacademy, and I'm thanking Unacademy to providing such a beautiful facility. Thank you.